All right, this is the flipped portion or semi-flipped portion of the muscular system. These notes are on my website, so I'm going to zip through these so you can just basically pause whenever you want. So types of cardiac muscle, same from the tissues unit way back first semester. Cardiac is not voluntary. Your heart beats on its own. It's only in the heart. It is striated and branched. So you see the stripes and they're branched. They can all beat together and there are intercalated discs. This next slide shows you these little intercalated discs. And of course, they're cross branched. They can all beat together. And of course, it's striated. You can see the little lines. Smooth muscle, remember, is smooth. It's involuntary. We don't think about swallowing with our food after we swallow it. It just goes through the system, intestines, and we don't think about closing our eyelid or our iris rather. They're striated. They're not striated rather. They're smooth. Makes up the organs, and again, your intestines, your organs, peristaltic movement through those, your rector pili muscle, and the iris of the eye. They also surround every small capillary in your superficial blood system. So the superficial blood, again, those vessels which feed your epithelial tissue, they're normally just feed the epithelial tissue. When it gets cold out, they constrict. They call it what's called vasoconstriction. They constrict it so it still feeds the epithelial, but keeps a lot of the heat in. When it gets hot, these muscles relax, let those blood vessels get extremely big, so more blood rushes through them, or more blood rushes to the surface. When more blood rushes to the surface, it brings more heat, and you get red and flush when you're hot because you're releasing more heat out to the environment. Says glands are also innervated. That means the nervous system says, hey, we're hot, let's sweat. So the sweat also brings moisture to the body. Evaporation of sweat is a cooling process, so it also helps cool off. All right, skeletal muscle, remember, is long and striated. These are muscle fibers or muscle cells. They're striated, all the stripes here. A lot of nuclei per cell, and they're all on the outside edge. So looking at it, it's a beautiful example of a skeletal muscle. It's voluntary. That means they won't move normally on their own unless we tell them to, unless we got some weird twitch. So you open your mouth. I open my mouth. I shut my mouth. I shut my mouth. Raise my hand. It's voluntary. They are lines and striped, and we're going to get into this big time now with the sarcomere. There are many nuclei per cell, which you can see under the slide. You can see many nuclei per cell. You cannot tell if it's voluntary or not by looking at it. You can only do that by doing it. And they usually connect to bones, but not always. The face, you can make the O sound without connecting to bones. Functions of muscles. So they help us move. They keep our posture straight up. They allow us to communicate. It's hard to communicate without muscles. You can't move. We produce body heat. The more you work your muscles, the hotter you get. So those are skeletal muscle, do the brown stuff. The green, number 5 here, is smooth muscle, organs and blood vessels. And finally, cardiac, the heart, pumps blood. All right, characteristics of skeletal muscle. We're going to deal with skeletal muscles from here on out. Okay, the heart is made up of cardiac muscle. Your intestines have smooth muscle for peristaltic movement to move the stuff. Now we're going to focus on the skeletal muscles, their makeup. Right now in part 1. Part 2, we'll talk about their general gross anatomy. All right, they're contractile. They shorten. They're excitable, so they respond to nervous twitch. I send a nervous action potential through my nerves, and that triggers acetylcholine to depolarize the membrane, and they're excitable. They will then contract. They also extend, they stretch. You can bend down, touch the toes, and you stretch those muscles beyond their normal resting period. But after you stretch them beyond normal resting, they're extensible. They also are elastic, and they retract back to normal position. All right, anatomy of the skeletal muscle. Remember, epimysium is the fascia surrounding a muscle. It's basically the connective tissue or fascia that encases a muscle. Within that, you have all these little bundles that you can see called fasciculi. Each fasciculi is surrounded by perimysium, peri, around, mysium, the muscles. It's the same material. It's a connective tissue, but it surrounds those kind of like insulates them like the cord does around a bunch of copper wires carrying electricity. So the fasciculi are the bundles of the muscle fibers surrounded by the perimysium, and the background picture shows it beautifully. So remember, epimysium surrounds it. The fasciculus is one, fasciculi is many. You see, these fasciculi are made of many little fibers. Each fiber is actually the muscle cell. Endomysium is inside, endo inside. It surrounds the muscle fibers and insulates them. So if I want to recruit just this fiber to twitch and not those, I can. It's not going to spill out any electricity. So paramysium surrounds our fasciculus. Each muscle fiber, again, is one muscle cell. Endomysium surrounds each muscle cell fiber. And there's the picture again. Endomysium does surround the muscle fibers, insulates them. Now then, muscle cells are made up of myofibrils. Myofibrils are these smaller little things you can see at the end here. Little fibril means tiny fiber, okay? But you see the muscle cell itself has a sarcolemma, fancy name for the cell membrane, nuclei, and the sarcoplasm, which is basically the cell cytoplasm of the muscle cell. The myofibrils make up one muscle fiber. Here it is. And there's a bunch of little sarcomeres. You can click on this link for the Khan Academy. Now we're going to go further. Myofibrils, you can see, are made of tiny little filaments. So we get threads inside of threads, inside of threads, inside of strings, inside of ropes to make the big muscle, basically. These little filaments are what you are going to also label. So you did this activity in class right here. Myofibrils are made of two types of proteins, the myofilaments that you just saw, called actin and myosin. We're going to go into more detail of those. So the actin and myosin, myofilaments make up the myofibrils. Myofibrils make up the muscle cells. Muscle cells, going outwards now, make up the fasciculi, and they're surrounded by endomysium. And the fasciculi are surrounded by paramysium. Paramysium and the fasciculi are all surrounded by epimysium to make the muscle. All right, sarcolemma, again, I said, is a fancy word for cell membrane of the muscle cell, the muscle fiber. So there's your sarcolemma, muscle fibers. All right, here remember the skeletal muscle is called skeletal because it usually attaches to bone by way of a tendon. Here you can see the paramysium surrounding the fasciculi, the epimysium surrounding the whole muscle, the muscle fiber cells surrounded with endomysium inside. And this diagram you will label. Take practice to label for the test. This is a beautiful diagram for the test. The sarcomere is the basic unit of function of a muscle cell. It's made of repeating units of actin and myosin within their Z bands. You can click on the little star down here and it will take you to a link from your textbook to show you a cute little cartoon animation of the sarcomere. So here's your sarcomere from Z band to Z line, Z line to Z line. The thick dark spot in the middle is the myosin filaments. The thinner filaments out here are the actin filaments, and what's really dark is the crossing of the actin and myosin together, and that forms the striations, the striped appearance, striations of muscles. All right, so again, actin is the thin filaments attached to the Z band. The myosin has these little heads. Those little tiny myosin heads use ATP to pull and close, to pull the actin closer together to contract that little sarcomere. Not powerful on its own, but you put millions of them together in your muscles and you can lift heavy things. Now what makes that, it doesn't act unless the active binding site is open on the actin. So down here, they zoom in on the actin. Actin has a couple other proteins surrounding it. It's got troponin and troponin. The troponin is like a handle attached to the tropomyosin. When calcium attaches to the troponin, it pulls the tropomyosin off the binding site. When it does that, these little heads then attach to the actin. These heads here of the myosin attach to the actin, and then as long as ATP is present, they start flexing. As they flex, they pull the two actin fibers together to make a flexing of the sarcomere. So acetylcholine, again, the brain says, hey, let's move my arm. So an impulse goes down, action potential goes down my nerve. It releases acetylcholine, ACH, acetylcholine. As soon as that's released, it depolarizes the sarcolemma, the cell membrane. And as soon as it depolarizes it, there's a bunch of enzymes out there called acetylcholinesterase, which immediately deactivate acetylcholine so you don't continue a flex unless you keep releasing it. But too late, that quick little flex released, depolarized the solar membrane. The cell membrane then allows calcium to bind to troponin. Once calcium troponin pulls the tropomyosin off the active binding site of actin. The actin then has myosin heads attached to it, and they will move. ATP, the energy allows them to move, and the muscle contracts. Now, these words are words. It's easier to see when you click on a diagram. It's repeated many times for one contraction of a muscle cell fiber. So if you clicked on the puppy dog here, it takes you to the McGraw-Hill website, and they take this in action, and they will show you how the calcium binds to troponin, pulls the tropomyosin off the actin, so these myosin heads can then bind to that, and it shows them contracting in a great visual. So click on that. I think you can do it through YouTube, I'm not sure. But if not, go to the McGraw-Hill website, copy that, and watch it. And here it is in a kind of cartoon format. The myosin heads bind to the actin. When they bind, they pull the actin fibers closer together. They close that gap. So that's a contraction of that sarcomere. This is what you see in college as they get detail. I don't get that much detailed. Again, the T-tubules, which I don't talk about anymore, get pretty detailed. Just remember, your body's very complex and very amazing. That's the only reason I put these here. I keep it super simple. You think it's tough. Yeah, it's tough, but not near as complex as I can make it. When a muscle cell is depolarized, again, the positive ions rush in momentarily, allowing depolarization, and the action potential then is from the nerve releases acetylcholine, which allows calcium to bind to troponin for contraction of the muscle fiber. Muscle is an all or none response. Each fiber either twitches or it doesn't, but you can recruit a lot of muscle fibers. So when I pick up something light, like a pencil, I'm only probably recruiting about 1,000 muscle cell fibers. When I pick up something heavy, like a desk, then I'm recruiting quite a few more muscle fibers, a lot more. There's 3 phases of contraction. There is the lag phase. That's the time between stimulus to start a response, which is very, very short, super short. My stimulus is, ooh, I see something scary. My eye detects it, sends it to the brain. The brain says, run. Sends a message down to my legs, and then my leg muscles start twitching, and I try to get out of there fast. That happens super fast. That's a whole lot of lag phases, actually. Contraction of the sarcomere. That happens pretty quick. Relaxation of the sarcomere. That again happens pretty quick. How do I know? Because I can slam my hand really fast onto a timer, pull it out the opposite way, and pull it back in again, start and stop the timer within 1/10 of a second. So there's a whole lot of lag, contraction, relaxation, lag, contraction, relaxation, lag, contraction, relaxations. Three of those cycles all within 1/10 of a second. So muscle twitch, the contraction of a muscle fiber is the response to an action potential. Know that. Remember that. The threshold, you say, get up, get your head out of bed. Finally, your mom yells, get out! You wake up enough. Threshold, enough stimulus. Okay, I'm awake. I'm moving. It's got to have a threshold, enough stimulus to react. And there it is. Lag phase, hardly anything at all. Contraction phase, like 30 milliseconds, fast. Relaxation period, it relaxes again. Tetany, I'm going to stop close to here. Tetanus is basically when the stimuli are so rapid or the calcium is not released that you get constant contraction. Okay, tetany is constant contraction of the muscles. All right, this is end of part 1 of part 1.